All right, let's talk about angular momentum. So I have the wheel here, and when I talk about angular momentum, it is a vector. So it does have magnitude and direction. So just as a quick review there, when I spin it this way, again, we're gonna always use our right hand. We'll place our thumb and bottom of our palm along that axis so that our fingers curl in the direction it's rotating. Our thumb will then point in the direction of the angular momentum. If I turn it the other way, you can see that if I curl this way, my thumb is pointing that way. And so right now the angular momentum is pointing toward you. If I move, it changes the direction that angular momentum is pointing. That's going to be helpful later on. Because if I want to change angular momentum, I need to apply a torque for some period of time. So for instance, if I get this spinning and then I set my finger on the edge, it will slow down over time. And that is a change in the magnitude. Now, if I get it spinning really slow and I apply that same force, you'll notice that it comes to a stop pretty quick. Short time to change a small amount of momentum. If I give it a lot more momentum, it takes longer for that same torque to change and make it stop. So if you give it more momentum, it just takes longer to change that to zero. Now, the same thing happens in the direction method. So if I hold it from this string and I let go of it, gravity acting here is going to cause it to tip over. So gravity is applying a torque some distance away from my axis of rotation where the rope is attached, and it tips over. Now if I give it angular momentum, in this case the angular momentum is pointing this direction, it will need to change the angular momentum's direction. Because of that change in direction, that torque can't make that happen as fast. And so it's going to take longer for gravity to cause it to tip over. The more momentum it gets, the longer it's going to take gravity to cause it to tip. Now you're noticing a couple things. You are seeing that it is starting to point down a little more. And as it points down, it's also starting to precess. And the reason for that is there's no torque in this direction, the up or the down direction from gravity. Gravity's only producing torques in the other plane, in this plane. And so as a result, as it tips over, there is now momentum this direction. Well, conservation of angular momentum, because there's no net torques in that vertical direction, means that it's going to have to precess. It's going to have to give momentum opposite to the momentum that is now pointing down. So as this one spins this way, you'll see that it precesses this way as it starts to go down. So as it goes down, the whole wheel is turning to produce an upward momentum. If I spin the wheel the other direction, you'll notice that it will precess the other way, because as it falls down, it's producing an angular momentum up. And so then this has to produce an angular momentum down to counter that, to conserve momentum. There's the wheel demo for you.